today we're going to talk about the real number system. So first let's clarify a couple of definitions. First, we have irrational numbers. Irrational numbers are numbers that cannot be expressed as a fraction. So for example, non-repeating, non-terminating decimals. So numbers that just go on forever. Then we've got rational numbers, numbers that can be expressed as a fractions. So fractions, terminating decimals, whole numbers, and natural numbers. Under rational numbers, we have integers, which are whole numbers and their opposites. We have whole numbers, which are the natural numbers, including 0, and natural numbers, which are our counting numbers. So 1, 2, 3, 4, and so on. A counterexample is an example of something that proves a statement to be false. So if I said, my shirt is red, you could counterexample that and said, no, it's purple. Well, indeed, my shirt is purple, so that is a counterexample. So we can use a big Venn diagram of sorts to show the entire real number system. So everything can be called a real number. Over here, in this side, we have our rational numbers versus our irrational numbers. Let's talk about irrational first because it's a little bit smaller. Keep in mind that it's all going to be a real number, whether it's rational or irrational. This side, irrational numbers, remember I said they cannot be written excuse me, as a fraction. They're non-repeating, they're non-terminating. So things like the square root of 2, square root of 5, and pi. And you know, of course, that pi, we all know it is 3.14, and it keeps going. Some people even have them all memorized. Okay, so that's an irrational number. So you can say that a number is irrational and real. So if I gave you one of these or something like that, you could tell me what it was. Now, over here, under rational numbers, it can be just real and rational, such as 2.75 or negative 5/3. Those all terminate. Now, if it's an integer, it's not only an integer, it's an integer, a rational number, and a real number. See how this works? We can have a whole number, which includes 0, 1, 2, 3, 4. Whole numbers are positive, though. But if it's a whole number, it's also an integer and a rational number and a real number. Then we have natural numbers, which are the ones that we say when we count. But if it's a natural number, it's also a whole number and an integer and a rational number and a real number. So this constitutes the real number system. So let's look at some examples and classify them. So let's say we're looking at the number 3. Well, 3 is a number that we say when we count. So it's a natural number. Okay. It's also a whole number. It's also an integer. Okay. It's a rational number because it can be expressed as a fraction. And it's part of the real number system. So the number 3 is all of them. What about negative 13th 20ths? Well, it's not a natural number because we don't say negative 13th 20ths when we count. It's not a whole number for sure. It's not an integer because by definition integers are whole numbers and they're opposites. Is it a rational number? It is expressed as a fraction, but we don't know if it's terminating or not. But it is for sure a real number. What about negative 5? Well, or not negative 5, excuse me, the square root of 5. When we take the square root of 5, if you remember, this was actually an example on the last slide. The square root of 5 is 2.23606, and it just keeps going. So it's a non-terminating decimal. Non-terminating means that it is Ernest can't spell today. Irrational. And if it's irrational, it's still part of the real number system. What about 0? Well, 0 is not a natural number because we don't say it when we count, but it is a whole number. It would be part of the integers, even though it doesn't have an opposite. It's going to be a real number, and it's rational. What about square root of 25? Well, if we simplify the square root of 25, we get 5. Well, 5, just like 3, is going to fall into every category. Natural, whole, integer, rational, and real. What about 3.14? We know that 3.14 is also sometimes used for pi, but remember that pi keeps going. This one is stopping. So this is not just pi in this case. This is a terminating decimal, 3.14. Well, when it terminates, it's a rational number. So just because I said 3.14, I'm not talking about pi. If I wanted pi, I would have put the pi symbol. And if it's rational, it's real. So when I talk about classifying real numbers, they should all have the word real beside it. And then you keep going. All right. So let's look at a real world scenario. Which set of numbers is most reasonable for each situation? The number of students in a math class. Well, what kind of number will we use for that? We would use natural numbers. Right? Natural numbers and real. Wouldn't be whole numbers because we don't need to start with 0. We would start with natural, the ones we count with. What about the distance from the main office to a classroom? Well, it depends on how you want to look at it. But it could actually be any of them. Because you could do it, if you measured it out, it could be a non-terminating decimal. But it's definitely a real number. So I'm just going to put real because we don't know the distance. It could end up being a decimal. It could end up being a whole number. We're just going to call it real. So let's look at counterexamples. Remember, that's something that proves the statement to be false. So if the statement is false, provide an example to justify. They may be true. All natural numbers are whole numbers. So if we look back at our thing, natural numbers comes inside of whole numbers. So can we say that all natural numbers are whole numbers? Yes, we can. So in this case, our statement is true. What about here? All rational numbers are integers. So let's look here. All integers are rational numbers, but all rational numbers are not integers. So if we take this back down, this statement is false. In our counterexample, we could say that some rational numbers are integers. We could also say that integers are rational. But we cannot say that all rational numbers are integers because of course we have numbers like 0.75 and 2, things of that nature that are not examples of integers. And that's how you look at the real number system.